Ever since we've been human, we've been explorers. We've crossed oceans, we've settled entire continents. But today, the next great migration, well, it isn't across land or sea, it's into the cosmos. We're talking about building actual cities in space. And this is moving really fast, from the pages of science fiction to the drawing boards of engineers.
And that's captured perfectly in this quote. The stars are not just for looking at anymore. They are for living in. I mean, that really hits home, doesn't it? This isn't just about some grand adventure. It's about a fundamental idea, securing the long-term survival of our species.
Okay, so that's the big dream. But it brings us to the most important question of all. How do we actually pull it off? How do we build our future out there in the cosmos? Let's break down the real-world steps, the massive challenges, and some of the incredible solutions that are being worked on as we speak.
So, our journey has to start somewhere close to home. And that somewhere is the moon. It's just a 3-day trip away, which makes it the perfect workshop, really. Think of it as our proving ground, the place where we'll figure out all the basics of off-world construction before we dare to go any further.
Right off the bat, we hit our first major hurdle. We can't just pack up everything we need from home. Why? Because launching materials from Earth is, well, astronomically expensive. We're talking thousands upon thousands of dollars for every single kilogram. At that price, even a small habitat would cost billions just to ship. So, building a city out of stuff from Earth, it's a total non-starter.
So what's the solution? Well, it's this really cool concept called in situ resource utilization, or ISRU for short. The idea itself is ancient, it's simple, you live off the land. We have to learn to use the materials that are already there on the moon to build, to survive, and eventually to thrive.
So how does this actually work in practice? Well, first, you'd have robotic miners scooping up the lunar soil, which is called regolith. Then, you process that regolith. Maybe you zap it with microwaves to melt it together into bricks, or you mix it into a kind of lunar concrete. From there, massive 3D printers would lay it all down, layer by careful layer, to construct habitats that are naturally shielded from the harsh radiation of space.
And, the moon is actually a lot richer in resources than you might think. We found water ice in the polar craters. That's huge for drinking, breathing, and even making rocket fuel. Of course, you've got all the regolith you could ever want for building materials, nonstop unfiltered sunlight for solar power, and maybe even a future superfuel called helium-3. It's basically a treasure chest just waiting for us.
All right, so once we've mastered the basics on the moon, we'll be ready to take the next giant leap, Mars. And this is a whole different level. This isn't just about building an outpost anymore. It's about creating humanity's first true second home, a whole new branch of our civilization.
But let's be clear, Mars is a whole different ballgame. It's way farther away. We're talking a 6 to 9 month journey one way. It has a thin atmosphere, sure, but that atmosphere can whip up dust storms that cover the entire planet. And the radiation danger? It's even higher than on the moon. The engineering challenges are just on a completely different scale.
You see, the core problem on Mars isn't just about building a shelter to live in. It's about engineering an entire, self-sufficient, breathable ecosystem from scratch. All on a world that is freezing cold, bombarded with radiation, and totally hostile to life as we know it. So here's how we'll likely do it. We'll start with these amazing inflatable habitat modules. You can deploy them fast, and boom, you've got a large living space. Then, over time, we'd build massive transparent domes to house parks and farms, creating these beautiful, Earth-like environments inside. And the whole thing would be powered by advanced, closed-loop life support systems that recycle every single drop of water and every breath of air. And get this, Mars's gravity is only 38% of Earth's. This one number changes everything. Can you even imagine being able to jump almost 3 times higher than you can right now? Architecture could be taller, more graceful. We'd invent entirely new sports that would be impossible on Earth. And over generations, it would literally change our bodies. Life on Mars would be fundamentally, physically different. But what if we think even bigger? This leads us to the most ambitious, most mind-bending vision of all, moving beyond planets entirely, to build whole new worlds from scratch, right out there in the blackness of open space.
So let me ask you a pretty wild question. What if we don't need a planet at all? What if the best place to live in space is just space itself?
This is the classic design for how you'd make that happen. It's called an O'Neill cylinder. So picture 2 enormous cylinders, we're talking kilometers long, rotating in opposite directions to stay perfectly stable.
That rotation creates centrifugal force, which gently pushes you against the inner surface. It would feel exactly like Earth's gravity. No more worrying about bone loss or muscle atrophy.
And this is where it just gets breathtaking. You'd be living inside an engineered paradise. Giant mirrors would direct real sunlight inside, creating natural day and night cycles. The landscapes inside would be built with soil mined from asteroids, complete with rolling hills, lakes, and even clouds. And right along the central axis, where there's zero gravity, that's your industrial park for all the manufacturing and heavy industry.
Now, the really crucial point here is the sheer scale. Just look at this jump. A lunar base could house a few thousand people. A Mars colony, maybe tens of thousands. But a single one of these orbital cities could be home to millions of people. It's a complete paradigm shift for what civilization off-world could look like.
Okay, let's zoom out for a second. Whether we're talking about the moon, Mars, or these incredible orbital cities, all these visions are really part of one single grand project, ensuring humanity's long-term survival by becoming a multi-world species.
And you know what? This future is probably closer than you think. This roadmap suggests we could see sustained lunar bases in the 2030s, followed by the first Martian outposts in the 2040s. By the middle of this century, we could see the first prototype orbital habitats, leading to genuine city-scale settlements in the 22nd century. This is a multi-generational project, and it's already underway. Now, all of this is going to be powered by a handful of revolutionary technologies. We're going to need AI-driven robots to do the dangerous construction work. We'll need biotechnology to engineer radiation-resistant crops, and maybe even humans. We'll need advanced propulsion systems to make travel between worlds routine, not a once-in-a-decade event. And of course, those perfect closed-loop systems for ultimate sustainability.
But you know, it's not all about the deck. The biggest challenges might not be engineering ones at all. Economically, how do we go from government-funded missions to a real private market out there? Legally, how do we figure out property rights, resource management, and citizenship in space? And ethically, we have some really deep questions to answer.
And this really brings us to the final crucial point. The engineering, we're getting there. We can actually see the path forward. But the biggest questions, the ones we have to solve, are human ones. Who gets to go? Who makes the rules? And how do we make sure that these new worlds we build are for the benefit of all humanity and not just a select few?
Ultimately, building cities in space is so much more than just a massive engineering project. It's our next evolutionary step. It's about securing our future from any single-planet catastrophe, and it's about unlocking a future of unbelievable abundance and discovery. We are truly on the cusp of becoming a multi-world species.